Chapter 8 in CIST 2612 is recovering graphic files. In this chapter, we're going to look at the different types of graphic file formats, types of data compression, how to locate and recover graphic files. We'll look at how to identify unknown file formats. We'll also discuss some copyright issues with graphics. All right, a graphic file is a file that contains digital photographs, line art, three-dimensional images, text data that's converted into images, and also scanned replicas of printed pictures. We do have three types of graphic files we're going to discuss here. We're going to discuss bitmap, vector, and metafile graphics. Bitmaps, there are a collection of dots, called pixels. Vector graphics, they're going to be based on mathematical instructions. And metafile graphics are going to contain, it's a combination of a bitmap and a vector. There are a lot of different types of programs that work with graphics. You have graphic editors. Those will be programs such as Adobe Photoshop or GIMP, Microsoft Paint. You also have other types of programs that you use to view the graphics, image viewers, a photo viewer, for example. You can also view these with programs such as Paint, GIMP, Photoshop, and so forth. You can also use those to view the images as well. All right, the bitmap images, as I said, were made up a grid of individual pixels. Pixels, there's going to be small dots that are used to create the images, and the term is going to come from the words, it's called a picture element. All right, so the pixels are just individual dots that are made up to combine to make the bitmap image. A raster image, that's a collection of pixels that are going to be stored in rows rather than a grid, as they are with the bitmap image. This makes graphics easier to print. They're usually going to be created with a vector graphic is converted to a bitmap image. So we also need to look at the image quality when we talk about different types of images. One of the things we need to discuss is the screen resolution, which is it's going to determine the amount of detail. It's the density of the pixels that are going to be displayed on the screen. So the better resolution, the better number of pixels, the better your detail you will have. We also will have software that will affect the image quality. So think of your drivers, and also the number of color bits used per pixel will affect your image quality as well. The main characteristics of vector images, one is we use lines instead of dots to create the image. So they only store the calculations for drawing the lines and shapes. They are a smaller file than bitmaps. And they also will preserve the quality when the image is enlarged. Now, two of the popular software that can be used to create vector images include Corel Draw or Adobe Illustrator. All right, so metafiles, they combine both raster and vector images. Metafile graphics inherit advantages and disadvantages from both types of these. If you enlarge a metafile graphic, the area that's created with the bitmap section will lose some resolution, but anything that's created with a vector format, it's going to remain sharp and clear. We do have some standard graphic file formats we'll discuss. That's common graphic file formats. This is something that all of the graphic programs and image viewers can open. We see our standard bitmap formats, the portable network graphic, the .png, the .jpeg, formats that you should be familiar with. We also see some standard vector file formats, such as the Hewlett-Packard graphics language, AutoCAD. Now, we also have non-standard graphic images. These are going to be software or images that will need a specific software to open. For example, Adobe Photoshop, the .psd files, that will need Adobe Photoshop to open the file, or a program that will open a PSD file. Not something that's going to be common for software such as like Photo Viewer, will not open those. So you may have to search the web to look for software that can maybe manipulate images that from these unknown formats or these non-standard formats. For example, if you're searching for a PSD file, all right, if you have a PSD file, you would know that is a Photoshop file. You can find programs available on the internet. I'm doing a search here on Google. Pull this over the screen. And so first thing is tell us how we can open a PSD file. So you see that it is an Adobe Photoshop. Adobe Photoshop Elements are the best programs. There are other things though as well. GIMP, for example. GIMP, you can open up a Photoshop file. You can do some editing to the image through GIMP, to that Photoshop file. Not as much as you can with the actual program of Photoshop, but that's just a limitation of the software itself. But that is something you could use to view the file and to open it up. All right, so witness or suspects can create their own digital photos. You know, we have some different types of file formats in here as well. We have the raw file format. That's what we refer to as a digital negative. This sum is typically going to be found on many higher-end digital cameras. Sensors in the digital camera record the pixels on the camera's memory card. All right, so the raw file format, it has no enhancement processing, so that's why it's called the raw format. This format will maintain the best picture quality, okay, but because it is a proprietary format, it's something not all image viewers are going to be able to display it. So you may have to check around for the correct software to view the file. Now, you can also, the process of converting raw picture data to another format is referred to as demosaucing. We're also going to look at the exchangeable image file format. So that's a file format that the Japanese Electronic Industry Development Association developed as a standard for storing metadata in JPEGs and TIFF files. Because this format collects metadata, investigators can learn more about the type of digital devices and the environment which the photos were taken. The EXIF files store metadata at the beginning of the file, and to read this, you're going to require special programs such as the XF Reader, iFrame Reader, or iFrame View. As you can see in this image here in Figure 8.1, it's really hard to tell the difference between the file formats. to the naked eye. When we go into figure 8-2, we'll see the differences in the header information, comparing an EXIF and a JPEG file header information. So using files such as tools such as Autopsy or EXIF Reader, in there you can use that to extract the metadata as evidence for your case. Now, also in this, remember that as in any digital forensic investigation, you need to determine the date and time for the file is important. You should list this type of evidence as subjective in your report because inintentional and unintentional acts make the date and time difficult to confirm. So we see an example here in 8.4. Using the autopsy is going to display the metadata from this file, this photograph file. We see the date the time was created, when it was last accessed, modified, and so forth in this data here. All right, most graphic file formats, they're going to compress their data. And this includes the GIF and the JPEGs. Other formats like the BIMP, they rarely compress their data. But for this, you can use data compression tools for those formats. So data compression, that's a process of coding data from larger to smaller forms. Graphic files and most of these compression tools, they're going to use one of two types of data compression schemes, either lossless or lossy. Lossless compression, that's a compression method in which no data is lost. With this type of compression, the large file can be compressed to take up less space than an uncompressed file without any loss of information. So once again, it reduces the file size without removing data. It's based on a Huffman or Lapel-Zide-Welch coding. And some utilities that can be used for this include WinZip, PKZip, and other zipping programs. The files that use the lossless compression include GIF or PNGs. The lossy compression, or the lossless. The lossy compression, it's a compression method that permanently discards bits of information in the file. And that removed bits of information is going to reduce the image quality. These are used in JPEGs. They do use the vector quantization for the algorithm, because that's a form of compression that uses an algorithm that's similar to rounding off decimal values. It's going to eliminate the unnecessary bits of data at the end. And as one of the utilities used for lossy compression is the LZIP. Now, tools can be recovered. The files can be recovered. You have different tools you can use. Some of these tools include, if you're using operating system tools, that may be something that's going to be really time consuming. The results will be difficult to verify. You can use digital forensics tools to help you analyze image files. So what you can do is these will allow you to analyze the image headers, so you can compare them with good header samples. You can use that header information to create a baseline analysis. There's also you can use digital forensic tools to reconstruct fragmented image files. They do this by identifying data patterns and modified headers. All right, so when we look at carving or salvaging, it's recovering any type of file fragment. Carving is the process of recovering those file fragments that are scattered across a disk. Salvaging is the same thing. It's just going to be used for outside of North America. And once again, you can use digital forensics tools for this. That will help you speed up the process for this. So they can carve from the file slack or free space, and they also help identify image file fragments and put them back together. There are times that you're going to have damaged headers. So you might find that when you recover these file fragments from the slack or free space, the data is going to be in the header. So if that header is damaged, or if it's partly overwritten, from there you must reconstruct that header to make it readable. So by taking the hexadecimal values of known graphic files formats, and you do this by comparing that to the file of the header you found, and it's able to then you can reconstruct the header. Now, when you do this, you keep in mind that each graphic file is going to have a unique header value. So we look at the example here of the JPEG file. It's going to have a hexadecimal header value, FFD8, followed by a label, JFIF, for the standard JPEG, and an offset of 6. So the exercise is to investigate a potential intellectual property theft by a new employee of Superior Bicycles, Inc. So we're looking at the example here of an email from Terry Sadler. And we'll start to look at repairing the damaged headers. So we're going to jump down and look at the steps when we were searching for or carving data from unallocated spaces. Okay, so the step one is going to be to plan our examination. Make our plan, the process we are going to follow. Then we're going to search for recovered digital photographic evidence. One of these ways is to use autopsy for Windows. Allows us to search for and extract or recover the possible evidence of JPEG files. Now, sometimes you may have a false positive. These are false hits. Stuff that's not going to be relevant to our investigation. Okay, so it may have a keyword. When we search for a keyword, it may pull up this file, but it's not relevant. It's going to be a false positive. So we're going to look through these screenshots of autopsy. You can see an example here. This is an altered file header. And in here, the file header is going to be overwritten with 4 Z's. So if I can zoom in on this. So we see that information has been overwritten. So right now we're looking through the game tour 2.exe file. If find out the information. In this case, the metadata is being pulled from this. All right, so when you need to rebuild a file header, first try to open the file with an image viewer first. Now, if the image isn't going to be displayed, you're going to have to inspect and correct the header values manually. A couple steps in this is recover more pieces of the file if needed. You want to examine the file header, compare it with a good header sample, or manually insert the correct hexadecimal values. And then you want to test the corrected file. So we see on the screen here an error message. Okay, this is going to indicate a damaged or altered graphics file, where it says it cannot open the file. So in here they come in, and in the offset position, they're working on reconstructing the header information. Now they inserted the header information for the JPEG file, changing information in the header. And this graphic here is going to show you the equivalence of hexadecimal values. So we see in here we have our first hexadecimal number, followed by our second. So we can look here that uppercase A is going to be 41. So that's the value to be inserted. And then we can now view our image once we reconstruct the header. If you've ever had a hard drive crash or accidentally deleted a file, there are programs you can use that can recover those. Sometimes it's not going to recover the entire image, and your image will come up such as this. Even though the file says it's there, the header information is damaged, so you can go in and manually reconstruct those. Now, if you have just the file fragments, what you need to do is locate the non-continuous clusters that's going to make up that deleted file. So you go in first, look and locate and export all clusters of the fragmented file. From there, you will determine the starting and end cluster numbers for each fragmented group of the sectors. Copy each of those fragmented group of sectors in the correct sequence to a recovery file. Rebuild the file's header to make it readable with a graphics viewer. And then you want to add a .txt extension onto all the copied sectors. Now, when you're identifying unknown file fragments, use the internet. That's going to be your main source of finding explanations for the and viewers for files that are uncommon or unknown image formats. We see a list of some of the websites that you can look up: fileformat.com, Extension Informer, Graphic Files Format Page. Your best search is going through a search engine such as Google. You want to look up maybe manifest-tech.com, searching for image processing tools. There's all kinds of options for you to use out on the internet. All right, you should also analyze graphic file headers when you find files that your tools do not recognize. With this, you would use a hexadecimal editor such as WinHex. It allows you to analyze for unknown file headers. So some example here is, for example, the XIF file format. That's old, little information about it's available. We'll see the first 3 bytes of the XIF. It's going to be the same as a TIFF file. So in this case, you build your own header search string. So we're seeing an example here of the TIFF file header. It starts with the hexadecimal 49492A and the equivalent in ASCII. We see the example here So once again, the XFI file headers 4949.2a. It's the same as a TIFF. All right, so there's not one viewer that can read every file format. So it is a good idea to have different viewer programs for your investigation. Most GUI forensic tools, they also include image viewers. It's going to display the common image formats, especially like something like a GIF or a JPEG. For less common file formats, most of the time they're just the integrated viewers are going to identify the data as graphics file, or it may be something that doesn't even recognize the data at all. All right, steganography is the art of hiding images inside of files. This is something that is an ancient technique. So we have two forms of this. We have insertion and substitution. All right, insertion is the hidden data is not displayed when viewing the host file in the associated program. With that, you would need to identify or analyze the data structure carefully. For example, that be hiding in the code of a web page. So in this, we see the example of this web page says the computer forensic book is using steganography. When we look at the HTML code in here, it is then revealed on the input type set to hidden. We have the value of this is an example of how you can communicate using web pages. Now, in web design, when you're designing with HTML, only the information that's displayed in between these body tags is what's going to be viewable by the users other than the title section in the head. So this is a section here that is going to be hidden, not going to be seen by the users until they view the HTML code. All right, the substitution steganography replaces bits of the host file with other bits of data. This is usually changes the last two least significant bits. And it's going to be detected with a steg analysis tool. All right, so when we talk about the least significant bits, that's the lowest bit value in a byte. So in Microsoft operating systems, bits are displayed from right to left. The rightmost bit is going to be the least significant bit. The operating system that reads bits from right to left are called little endian. Operating systems that display left to right are called big endian, and it's spelled E-N-D-I-A-N. So we're going to look at table 8.1. So we can see how the original pixels versus altered pixels. Look at the difference between these here. So we start our original pixel is 10, 10, 10, 10. So our altered pixel is 10, 10, 10, 0, 1. Original pixel for the next line is 1001 and 1101. Altered pixels is 1001 and then 1110. So we see that there is some difference. So let's look at the altered image file and the original image file. We see how there's a little difference in these. graphic files. It's not something you really see well on this screen. But there is a hidden message in the altered system. Because we've seen now that we have the account numbers and passcodes hidden in the altered image here. This is something that you would need to run it through the analysis program. So in this, we'd use the steg analysis tools. These are called steg tools. They're going to be used to find information hidden in the graphics images. Now, this can be a very time-consuming task. Now, when it has been done correctly, though, when steganography is being done correctly, most cases you can't find the hidden data. So it's looking for variations of the graphic image. So some of the benefits of using a steg analysis tool include that it can detect variations of an image. It can look at the file form, identify the file format on the graphics file that has been renamed, and also indicate whether a file contains an image. And we do have to be aware of copyright issues with graphics. So steganography has been used to protect copyrighted materials. It may have a digital watermark on the image files being put in for inserted for copyright purposes. So as an investigator, you should be very careful when analyzing image files. You want to make sure you avoid copyright conflicts. You can check out the U.S. Copyright Office, copyright.gov, for the copyright laws for the United States. That does identify what can and can't be covered under copyright law in the U.S. Now, one thing is there is no such thing as international copyright law. So the laws for the internet, they're not really clear. All right, so this week we'll discuss chapter 8 as we looked at the different types of graphic files, steganography, different types of compression, recovering image data, reconstructing headers, rebuilding image headers, looked at steg analysis tools. One thing we didn't discuss is the fair use. You have to consider that when dealing with copyright, because that allows the copyrighted material for use for non-commercial or educational purposes without having to compensate the material's originator or owner. You could also think this is something that may be used for a news story as well as part of the fair use. So that covers chapter 8 for CIS 2612.